Now let us try to compare the tails of the normal distribution against the tail of a gamma distribution. So what I have written down here is the density for a normal distribution and the density for a gamma distribution. And what we have is, so what we have here is the density for their normal distribution, and below we have the density for the gamma distribution. And the assumptions we have are that mu is a real number, so mu is a real number, sigma squared, alpha, beta are all greater than 0. So let us try to check which distribution has the heavier tail. The way we're going to do this is to take the ratio between the two densities and see what happens. So note that I've written here, let tilde denote proportional to, and the reason why I do that is because when we compare the ratio between the two densities and let x go towards infinity, then the constants, such as this part and this part, they don't really play any significant role. So we don't want to lug around with these constants and keep writing them all the time. So the thing I'm going to do here is, so we consider the ratio of the densities. And I call this ratio h of x, which is then given as, well, I can kind of choose which density I put in the numerator. But if I put the normal density in the numerator, then I will know that the normal distribution has a heavier tail than the gamma distribution if the ratio goes towards infinity, and if the ratio goes towards 0, then I will know that the normal distribution has a lighter tail than the gamma distribution, right? So this notation just stands for the density for the gamma distribution with these parameters evaluated in x. So what I will do now is I will write up their expressions but without the constants. So this just means that the ratio between these two densities is proportional to what I write up over here, which is just the ratio of the densities, but without the parts that don't depend on x. Divided by x to the alpha minus 1 e to the minus beta x. Now the thing is, what we notice quite quickly is I have an exponential here and I have an exponential here, and they're not that fun to play around with, which is also why we can use the trick from the exercise notes that tells us that we can look at the tails by considering the logarithm of this expression instead. So that is what we will do. So hence, the logarithm of h of x is equal to, so I take the logarithm of the numerator and subtract the logarithm of the denominator. That's actually just the same as taking the logarithm of this whole expression, right? And if that logarithm goes to infinity, then I will know that the normal distribution has a heavier tail. And if that logarithm goes to 0, no, sorry, this is wrong here. It needs to go to minus infinity. So if that logarithm goes to minus infinity, then I will know that the normal distribution has a lighter tail than the gamma distribution. So let's do this. I have log of h of x is equal to, so I take the logarithm of this, and remember that there was actually a constant that I removed, so just to take that into account, I just write a constant k here and add it on. So log of h of x is equal to some constant k plus the logarithm of this, which is actually a minus 1 over 2 sigma squared multiplied by x minus mu to the squared. And then the division, it's translated into a minus when I take the log. And then log of x to the alpha minus 1 is alpha minus 1 log x. And I then have minus log of e to the minus beta x, which is minus beta x, so that's plus beta x. So what do I notice here? Well, basically what I notice is I have a term with log x, a term with x, and a term with x squared. So this term with x squared will be the dominating term as I let x tend to infinity, right? So this is the dominating term for x going to infinity. And what we notice is that this dominating term, x squared, has a minus in front of it, which means that all in all, this expression will tend towards minus infinity as x tends to infinity, since when x tends to infinity, x squared tends to infinity, and minus x squared tends to minus infinity, and the rest of the terms just aren't significant enough to play in. So what I see here now is that log of this minus log of this tends to minus infinity as x tends to infinity. And based on what we learned from the exercise text, this means that the normal distribution has a lighter tail. So the normal distribution, this isn't going that well. So the normal distribution, regardless of parameters, will always have a lighter tail than the gamma distribution.